Hi everyone, so I'm Chetan Khatri. So today's agenda, we'll talk on Apache Spark and Scala. So if you know the traditional ETL tools, like people are working on Informatica Power Center, Talend, SSIS, and there are so many tools, okay? So that tool is used to do data exchange, okay, code migration with the help of ETL tools like Informatica Power Center and Talend and so many other tools where what people do generally that they have source and they have target, and then they will create the mapping, create the workflow, maplet and session, and then execute the session. So what will happen? So when you execute the session, at that time data will get exchanged over there. So if you have source and target, you will say you want this data could be transferred to the target. At that time it will get transferred, right? So these tools are very expensive tools in terms of industry. Informatica, Power Center, and the MDM, they have DTGX, entire studio that you buy as a license is very expensive. Plus, it can only execute and run on the Windows platform, which is again you need to pay for the licensing on the server and entire cluster and everything. So from last couple of years, like 5 years, people have industry has started to move towards the open source technology stack with help of Hadoop, Scala, Spark, and HBase, and different technology tools stack like Hive and different stack. So one of the popular tool from entire ecosystem is Apache Spark. And Apache Spark, so the goal of today's agenda is we'll talk on Apache Spark and Scala and how those people are interested to work on distributed computing. Those people are very interested to work on big data and kind of that. So how you can just do transition from traditional tools and technology to the big data, Hadoop, and distributed computing. So that's all about that. So I set the expectation that what you will get after this entire session. So I understand that the audience we have has understanding of what is big data, okay? What is, because you people are working with different tools like Informatica Power Center, Talend, and everything. And you understand the SQL transformation, Java transformation, how it works, right? So having understanding of the Java as a one programming language, Spark is built using the Scala programming language, which is executed on top of the JVM itself, but functional programming language. So we will talk on why Scala is easier when you do transformation and everything with the Spark. When you want to write the job with help of the Spark, you can use the Scala, Java, and Python and R. For programming language choices there. So who am I? I'm working in Axion as a lead of data science from last 2 years. Prior to that, I was working with different companies. I am an open source committer in Apache Spark, HBase, and Elixir language. Apart from that, these all are the past and future conferences that I spoke, a couple of them in future where I'm speaking. So as I said, agenda is we'll talk about Apache Spark and Scala. We'll talk about primarily abstraction of the distribution set in the Scala, which is RDD, resilient distributed data set. And we will talk about data frame, dataset APIs. We'll talk about what are the operations can be possible with Apache Spark. And then we'll talk about data platform components and re-engineering and how to think that can make efficient code in your Spark and Scala. So Apache Spark is general purpose, fast and computing framework, which is a unified engine to process big data, okay? And it provides the high-level API in Scala, Java, Python, R, and optimized engine that supports general execution graphs. And it has 4 modules. One is a Spark SQL. So whatever operation that you can do with the SQL API. So if you are working on SQL transformation, and then if you want to do join and transformation filter, all the SQL transformation that you can do, that can be done with Spark SQL API. And we have MLlib. So MLlib supports the machine learning platform. So the biggest problem in the industry was when you work with machine learning, it requires that data should be on same node. So when you create the entire cluster, your data, training set and test set should be on same node. And that's where it was not having that much efficient and parallelism and performance over there. So what community did that they created the upper wrapper on top of the scikit-learn, and the Python and created Scala APIs. That's known as the MLlib. So you can do all algorithm in machine learning like regression, classification, deep learning, reinforcement learning, whatever it is, and which is a very high level API. I mean, you don't need to learn mathematics to do algorithm in machine learning with Spark. You just call the API the way you call in Java. And we have GraphX, which does the graph processing of the edges and node and everything the way you do in graph-based technology. Spark also came up with the Spark streaming and structured streaming. So when you have flow of the data without stopping the connection between the server and client, those APIs are being built on top of the Spark. So that's a Spark streaming and structured streaming. Again, is a very high level APIs. Means you can say you want to read the stream X ABC, and then you can directly get SQL transmission on top of that. So that does mean you don't need to write too much algorithm to compute that, but it's very high level APIs on top of that. So what is Scala? Scala is one of the modern functional programming language which supports the strongly type and type inference paradigm. So one of the difference between the object-oriented programming language and the functional programming language is that you have everything, data type is immutable. Second thing, that you have all the functions. The way you compute in a lambda calculus, like the way you do map and flat map and all the function, the way you apply function, it works based on that technology stack and theory. But the still Scala runs on top of the JVM. It can support the object-oriented programming language also. So Scala is, I cannot say it's very pure programming language in functional way, but it supports both. Okay, but if you want to gain the real performance of the functional programming, then you need to write the Scala code in functional way. When I say functional way, then you don't have kind of for loop or while loop and kind of looping structure, but you have everything function. If you do map or flat map and kind of way, and as everyone sees right now that all the programming languages are going towards in a functional way, whether it's TypeScript or Angular 4 or React or even Java 8 and 9 and 10 now, I think. So everything is becoming on functional way. Why? Because they understood based on the JVM performance, right? That you can have efficient code and you can reduce the inefficiency of the object-oriented programming language. But some of the concept like class and interface and those things that still you need, even though in functional programming, then you can create that, but the computation will work on functional way. It supports the higher order function. So higher order function means what? You can create the function which can also return the function, which can also take the argument as a function. Okay, so you have those kind of state where you pass the function that can return the function, and it has a value as a function. Okay, so everything that you has a function, even though you create your variable, you can still pass the argument to that variable, and that can return the one more function. It supports the lazy computation. Okay. They can't see.
Yeah. Desktop karo.
Now.
I think so. Let's see. I'll ask. Don't worry. You continue.
It supports the fundamental of lazy computation. Means when you work with Spark, you have two operations. Okay, one is the transformation and one more is action. Okay, so the API has abstraction. They define what to call action, what to call transformation, and so generally it creates the graph in terms of DAG, directed acyclic graph, and that graph has different nodes. Node is a one transformation, and when you apply the action, so it will validate the entire graph whether it's correct or not. Whether it's, if it's correct, then only it can execute the entire graph. Means entire execution steps. That's called query plan or something in when you work with SQL Server and kind of that. Till now, any question?
Yes, is Scala built on Java or?
So the founder of Scala, Martin Odersky, he started creating own compiler with the comparison with the JVM, right? Okay. But since all days, he wanted to build the compiler, but he came up with the programming language. It's a functional programming language. So it removes the side effects of there's no exception catching or kind of that. If you want to apply, then you can do, but the way best practice suggests that you should not throw exception, because if you throw the exception, what will happen? Entire program will get stopped. Okay, so they say you do not throw exception, but you return some value like 0 or something value you return. So it will not stop the entire fundamental. The advantage with the distributed computing is what? That you have the program is not running on one machine, it's executing on different nodes. So the cluster is nothing but the group of computers. And the other advantage because of cluster is that you can use a open source environment like Ubuntu or CentOS and system based on Unix and Linux. So those are free also. And when you get that, for example, if you have Windows, you have so many things installed over there, right? So it also consumes some of the resources like memory and disk and everything. But when you get vanilla layer of the Unix, you have those processes that you only need.
So for example, now I'm processing 1,000 records. 1,000 because I'm processing, but I got errors in between. So it will not, as per the statement, it will not stop in between, it will continue to do it.
Yeah, but if you have the requirement that if there is some exception or something that you want to stop that execution, then you can explicitly you have to write.
Correct. So if I don't want to stop, but I want to error out the failed ones so that I can retry later part of time.
Yeah, say for example, you have 10 tables in source, you have 10 tables in target. You are doing just data exchange. You are transforming data from source to target.
Correct.
So let's say in fourth table, 4 to 4th, it got failed.
Correct.
So if it's Java, what will happen? Everything will get stopped, right? So if you go ahead with the distributed fashion, what will happen? The 5th, 7th, 5th, 6th, 7th, 8th, 9th, 10th, it will run. So at least one table is not there, right? But the other problem in big data, like when you talk about terabytes of data, petabytes of data, because of one exception in one transformation, you want other data to be transformed at the same time. Otherwise, again, same program will take 10 hours, 12 hours, right? So if there's a one issue, then you can transform that one issue and fix out.
We have notifications where we get to know.
Yeah, you have to customize that to make it notification. Okay. So basic data structure in Apache Spark are RDD, data frame, and data set. You can see.
I can see on the
Zoom,
screen.
right?
Zoom,
Yeah.
Zoom.
So what are the RDDs? We'll talk. So RDD is a logical model across distributed storage on cluster. So RDD will be, so if your data set of 5 GB, it will be splitted across all the nodes. So by default size of the one block is 128 MB. Okay, so if you have one large file, think in that way you have a large file of 2 GB, right? Now split those files in different block and distribute to different machines. And then apply your function like map or transform, whatever. It could be join, it could be filter, whatever you want to compute, whether it's combine of everything. Those your computation could be applied on different blocks at parallel time. And the output will come together. Again, it will be combined together. So it is faster because in this way. So this, whatever you can see as a disk, it is HDFS, is a Hadoop distribution file system. You can also use cloud-based storage, distributed storage like S3 and Google Cloud storage.
But in Google Cloud, we are getting different tools.
Yeah, sorry.
In Google Cloud, we are getting different tools. Like
Yeah, so these tools I'm talking about are open source tools. When you talk about services provided by cloud provider like AWS, Google, or what do you say? Forgot third one. Microsoft Azure, right? So they provide services to you, and they used to manage the infrastructure. Here, everything is vanilla. Okay, you create by yourself. You have control on that. You have permission on that, and there's no cost here because everything is open source, and you can use bare metal hardware. You buy from the hard disk, and then you can create in that way your own data center. But when you talk about other tool provided by Google Cloud like Dataflow, Dataproc, right?
Dataproc,
And they have, Amazon has a EMR, right? And Kinesis, those kind of tools are chargeable to you for each and every records, right? If they charge like 1 cent for one record.
Okay.
And the problem with those kind of infrastructure is that when you when you are doing POC or testing something, your code is not working, till you are processing those many records. Like if you have, for example, 30 TB of data, you process that and you'll hit the big bill because you process the at list, okay? In that way. But in bare metal, you don't have to pay anything, it's free, right?
Yeah. But nowadays, people are shifting towards these cloud services and all, right? What are the
It
reasons?
depends. I mean, in Axion customer portfolio, most of the customer that we have worked on, having everything on premises, like Express, okay, Walters Fluor, and MSA, they had own data center, right? Even, I mean, they are cloud provider, Express, they have own services to provide, but they also have different teams and they work together on that.
Will there be any difference between cloud services and
So to be honestly, it's nothing. Use open source tools,
okay.
build it, package it, and sell in market. So
Okay.
that's what they are doing. They themselves says on the documentation is nothing but Apache Spark version 2.3.0. Okay, and they provide the API on top of the wrapper. So you can just use REST API and JSON payload in terms of data,
Okay.
but you cannot customize. Even though you know how it works, but you cannot customize. Okay.
Okay.
If you want customization, then you have to go with the open source way. Most-
Customization in the sense what?
Customize in the sense the technology, the way technology work, right? The way it has been built. If you want to customize based on your requirement, okay. We'll come to those kind of questions after
Yeah, yeah.
that. Okay.
Your laptop mic is working. Sorry.
Mike,
Yeah, I can.
I'm just interrupting one question.
Yeah.
In Google and all, you talked about different APIs, tools kind of things, right? The data flow and data prep, they are all like
Data flow.
APIs or they are like tools?
so you have to submit your jar, upload the jar, and they will take care about orchestration and clustering part.
Okay.
Here you can submit and you can monitor and see what's happening in your code. Okay.
Who does the orchestration?
Orchestration done by Google. I mean, there is a tool called Yarn. Yarn does the orchestration, but I mean, you can customize anything to anything. You can use Kubernetes to orchestrate on the cluster, and you can use a Docker also.
For that also, we have to write scale-up programming or it's a different?
Even though you use Dataproc or EMR, you need to write your program in Scala or Python or Java or R, right? The Spark provides you freedom to write the program the way you want, but there is side effect on every programming language. Only the best practice and efficient way to write code is by using Scala. Okay.
But what I see here is like it's all like the data processing, but where the ETL part will come in this case.
So ETL is nothing but extract, transform, and load, right?
Yeah, right. Yeah.
So you have two tables in MS SQL Server. You extract that, store into variables.
Yeah, right.
Okay, and then you say you want to join with third variable. Okay, and then you will say you want to filter that because you have own condition on join.
Okay.
Okay, and then you will say now store this data to Excel or CSV or PostgreSQL, right?
Okay.
That does mean ETL.
Okay.
So that does mean ETL. ETL is nothing but extract, you transform the way you want, and again load data back to somewhere. So ETL you do, or you do ELT for extract, load, and then transform.
Yeah.
Both are being supported in this architecture, these technologies. Okay.
Because normal ETL, what we have is like we have different source systems. They are like transaction systems. From there we take the data to the data warehouse.
Agreed.
But in this case, which is our source, because I can see that all the data is stored in HDFS or something like that. So from HDFS, you take the data and store it in which?
I think you will understand better once this session is over,
Okay.
and then we can talk offline if you need more
Yeah,
information that how ETL can be done, or we can have separate session on that. Okay. But without this, you won't be able to understand ETL also. Okay. So we are going further on this. Yeah.
Sorry.
Yeah, no problem. Yeah. So I'm saying that RDD is one kind of resilient and immutable data set. So that does mean if there's some failover, RDD has the capability to recover it and came into original state. In a sense, you create the graph, one source, then you have filter transformation, you have join transformation, you have left outer join, you have outer apply, you have left apply, whatever it is, and then there is one indexing part which got failed. That doesn't mean everything will get failed. So if RDD has data, it can recover and back to that, because it could be possible after that you have second transformation, which is again doing join and filter and again left outer join and full inner join, whatever, right? So it has capability to recover internally and back to the original state. Immutable means, as you know, immutable, right? Everyone knows that you cannot change the data. Okay. Why? Because it is distributed framework and it requires parallel threading and kind of mechanism, distributed things. That's why it's immutable.
So how do you change it?
You create one more variable and assign that data back to
Copy it
that.
and
Automatic. Yeah.
already I'm not getting exactly what exactly it is, like list, dictionary.
RDD
The new data structure
is a new data structure in the Spark framework, built based on Scala framework. Okay, Scala programming language.
Okay, so
That's it.
So,
Physically
like,
store any data.
you have a type like integer, character, like you have type
Or
as RDD.
you're talking like that. You can
Yeah.
create RDD of any primitive type. You can say RDD of integer, RDD of string, RDD of whatever,
So multiple
list or something or whatever, right? So your object-oriented object, you can create RDD of any object. You can create RDD of files.
Immutable as well.
So then it converts that primitive type of data to immutable and distribute it, and then execute all the function on top of this RDD.
You have like millions of records, so like you have to create again a new one to update.
No. If you have like billions of record, then what is that? You will create RDD of row,
Okay.
RDD of table, right? So they have, I mean, the entire Spark framework has this kind of this kind of data structure where all the common operations can be combined, like table or row or data set or join or filter.
You do create RDD for it, tag, table, or just one thing, the immutability part here actually. It's like if it becomes immutable, then we have to copy the whole table into a new one to get it updated eventually the new data.
No, technically, you will not just copy. You will apply some transformation, right? Let's say you have one RDD, okay, of entire table, and then you say you want to take filter where city is Ahmedabad and state is Gujarat, and then you get all the data over there, okay. And then those data, because size is less than the primary RDD, right?
So it's a big file, big table, no sir, big table actually. Millions of records
So-
inside and we
When we are talking about, for example, billions of record processing, you have huge amount of disk and RAM here, right? Because it's cluster at the end.
so it will be in memory in that case.
Yeah, so Spark works on in-memory computation mostly,
Will be
but it can also orchestrate the disk. Okay, so you can spill over your data which is not fitting in memory to the disk.
okay, but to process it, you have to pull it into in memory.
Yeah,
To process it, you have to pull it into in memory.
in memory. Okay, so
But it does use different nodes, right? Like,
it does use. So
The nodes
when you-
you said there's databases there. That means there are multiple nodes to store the data.
yeah,
When
yeah.
it comes to processing, both node might not have the process actually.
Can you please come again?
If the nodes, those are data nodes or what sort of nodes they are?
Yeah, so I mean, when you create the entire cluster, this is entire different topic. It's known as the Hadoop administration, right? When you create the entire cluster, you have data node and name node. Okay, name node is nothing but the driver nodes, and other are kind of worker nodes. Okay, so driver node can manage only job orchestration, job tracking, which job to execute, and everything. Data node is used to process the data. But it again depends the way you write your job and code, okay?
so I think memory is
SDFS would not be part of the nodes at all.
Obviously, because HDFS is nothing but the disk, right?
Yeah.
So first you need, when you create the cluster, you have to provide the disk. I mean, at the end, you have node, right? It has what? Cores, 8 core, 16 core, RAM, disk, right? So when you create the cluster, it will allocate those disks, okay, to the HDFS, okay?
Okay. So like we have 10 terabytes, so a few GBs, one SDFS nodes. It has the ability to get processed as well.
So the expert in this domain create the cluster based on the requirement of the data, and basically by default the replication factor is 3. That does mean you have 3 copy of data in case some node get failed. Okay,
But also this is also distributed, right?
distributed fashion, right?
So the processing can be distributed. And,
No, it is. I was just wondering about the immutability part. So like if you have big data being processed, so if it is immutable, that means we have to copy it to get the new one actually.
New one in the sense, technically,
New, means so some fields were modified. You're
some
saying
field
that
is,
the data we have like tuple. You're saying if I want to modify second element, we can't do it. So we need to copy the entire data.
it depends. See, it depends that if you have only one tuple with 2 elements, then you can create the variable which can be modified, right?
Yeah. Okay.
If you know that, then when you have data which is very huge at that time, because if it's not immutable, it cannot do distributed computing because if you have 8 nodes, right?
Distributed is particularly for that we have data spread across multiple places.
Yeah.
Immutability might not be exactly the rationale behind such structure. Maybe let's proceed.
Okay.
I can answer it.
Yeah.
So one more thing, like you talk about RDS as a in-memory process, right? You transfer the data one time or for every
So actually, I have to speak on data frame, data set, and then only we can talk that what is difference, where to use that, and then we can understand that.
maybe you log into the cluster and show the time.
Yeah, I mean, we will do that.
And the RDD is it kind of row or a table, right? So
RDD can be anything,
anything.
any data.
And it
It
has
can be
multiple
graph,
data.
it can be whatever you want. Okay.
So can you have multiple data types within a single?
Yeah. Since Scala is based on top of the JVM, whatever JVM can support can be done here.
Okay.
So yeah, that's why I'm coming here. So compile time safety and strongly typed inference can be provided with the Spark because you can create RDD of integer, you can create RDD of string, you can create RDD of text and double and binary, whatever you want. Lazy evolution in the sense, if you have multiple transformation, and then you are providing action, that does mean that when you provide action, at that time entire DAG will get executed, and at that time it will only perform the processing. So Apache Spark operations are divided to transformation and action. Okay. So these are the transformation that you can see: map, and this is filter, typo here, flat map partition, and you have group by, sort by, and sample, random split, union, intersection. And these all are the transformation. Action are reduce, collect, aggregate for the first tag for each top tree aggregate, and those are the wherever you do something computation like count, max, mean, sum, histogram, mean, variance, or standard deviation, or sample variance. These all are the action. Okay. So you can create your source, then you say map, then you say filter, then say map, flat map, then again you say join or union and subtract and distinct of the value, then you again do Cartesian join. So this will check entire graph whether the this issue or this error in the type safety or somewhere else, and then when you say count, at that time it will only get executed entire graph. Okay, I will show you some demo that I have. So now I think now question is that when to use RDDs. Okay, so when you care about control of data set and knows how data should look like, and you allow low level API, you can use the RDD. When you don't care about a lot of Lambda function, then DSL means a domain specific language that Scala provides. When you don't care about schema and structure of the data, by the way, RDD is not structured. Okay, so your first question that you can fit entire table to RDD. Okay, you can fit, but not as it is, because it has a structure, column name and metadata and everything. So don't care about optimization and performance and inefficiencies. At that time you can use this RDD. I'm very slow for non-JVM languages like Python and R. Okay, and when you don't care about inadvertent inefficiencies, what is that? I will talk later. Before that, if I have, I'll talk on data set. If I have data frame, yeah. Okay, so structured type of data in this Spark is data frame and data set. Data set is strongly typed. You have ability to use powerful Lambda function here. You have ability to use Spark, SQL's optimized execution engine like Catalyst and Tungsten here. Can be constructed from JVM object, and you can change that to functional transformation like map, filter, and flat map etc. Data frame is a data set organized into named columns, okay? And data frame is simply a type of alias of data set of raw. So the difference between data set and data frame is that data frame can have untyped data, where if you use data set API, you have to provide the type safety here. And data frame can have named columns, means you have name with the column and type of data, the way you create SQL way, more or less. Yeah. And the structured API in Apache Spark, the basic difference is that, so we have three APIs here, SQL, data frame, and dataset. So when you only use SQL way, it says Spark can also support SQL way. You provide entire SQL string and say spark.sql and provide SQL string and then fetch data, right? But the problem is that if you are working with 61 TB of data, for example, which takes 10 hours to process all the data, and if it, so the exception after 8 hours saying that there's error, the column name is not there. Those kind of exception can have, okay, but it wastes your time, like 10 hours or 8 hours, right? And data frame can have compile time safety on syntax error, but not on analysis error. So analysis error is like column is not there, or table is not there, or type mismatch in the column in the table like that. And dataset API provide compile time safety for analysis and syntax also, because you map it all the data with your object and then you perform the operation on top of that. I have example on that, how it look like that. So analysis errors are caught before job runs on the cluster. So you can save your runtime and everything here. So as I said, dataset API came in 2016 in Spark, which is a type dataset of T, means you can provide any type here. T means type inference, okay, in functional way. So I mean, you have to think in any type, means any type. You say type of table, type of SQL, type of integer, whatever you say. If you create Java POJO and then you say type of that POJO, it also works. So this is data frame API code, okay? So you have an RDD called past RDD, okay? And then you wanted to get 2DF. So you can convert your RDD to data frame and vice versa, data frame to RDD. So here, you know, you have 3 columns, okay, but without column names. It says you know the kind of structure of data when you create the RDD, because you have created a sequence and list of that. So you know it looks like in terms of tabular way, okay. So if you map the column names, it will become the data frame, okay. So here we have RDD, past RDD, which is nothing but the sequence of some key value pair, okay. So you said here that past RDD.2df, project sprint and number of stories. Now you want to do data frame to filter, okay. So it looks like that you can do SQL here for this also, right? This combine, those people are understanding SQL, they understand that they can do SQL script for this also. But you know that how it differs when you go with SQL way and when you go with a data frame way and when you go with a data set way, okay, to save your time. And so there's a called project is equal to finance, and then you want to do group by on number of sprint, and then you want to do aggregation function, which is sum number of story as count, and then you want to do limit 100, and then you're saying so of 100. So here, I mean, those people understand SQL, they will be able to write this code better way, because they know if you do limit, it will only get 100 data rows on the cluster. So as less data you bring on the driver node, which is nothing but the name node. So it is much more efficient for you to manage, okay. It's not like you have terabytes of ATFS or disk or memory of GBs, right? You have to make sure that you can run n number of jobs parallelly. It's not one job in a Spark it runs, right? If you run n number of jobs parallelly, it can compute everything together fast way, okay.
You're saying that all the jobs are sent to particular nodes and they run, and
it cannot be assigned to particular node single job, but single jobs the data will be distributed across to each and every nodes. If you run 5 jobs parallelly, it depends that whether cluster will allow or not based on number of virtual core and number of executors and RAM and memory. But you can also assign the hyperparameters on when you run that job. like number of executors, number of cores, number of driver memory, number of executor memory. So if you want to compute that how many tasks can run parallel, that it is equal to number of executors into number of cores. Core is nothing but the CPU power, 8 core, 16 core. Okay.
So the name node will take care of that. Like how do we?
Name node will take care whether which node has remaining memory, which node has virtual core. I'm not talking about things like that. When you run 5 jobs parallelly and one job is completed, so that node is free, right?
When we do the filter, birds plus the finance. So now what happens? Like the job gets submitted to a
So
customer
till this time, you do the filter. Okay. See, if you
the
see
data
this
could be
slide,
spread across multiple nodes
No.
or in a cluster.
yeah. So if you see the transformation, right, all the transformation can be done on worker nodes. When you talk about action, at that time it will bring on the driver.
But but the data might be spread across multiple nodes.
Data is first speed to multiple nodes, right? But you can apply same function to all the nodes. And once computation is done, derived value you bring to the driver. So it can be aggregated together.
Okay, so it is running on the multiple nodes then.
Yeah, that's what I'm saying. Data is splitted and some same computation are running on multiple nodes at the same time. That's how you can use all the cores and memory. And once computation came out, okay, then you need to bring to driver, because then only it can send to somewhere else. And that's why as much as processing you can do on the worker nodes, it is advisable to do on worker nodes. If you
any particular element that does it transforming all the thing here, like
it does.
when it-
See,
when
for
you
example,
it takes the job.
this all actions, right?
Yeah.
It does. Even you call it reduce or collect or fold or take. Okay.
A lot of abstraction.
So-
actually, that's what, right?
Yeah, it's very high level API. Okay. So we were talking here, right? So filter and group by both are what? Transformation. So it does the filter on each and every nodes, for example. So if you have
Be careful.
first node here, second node here, third node here. Since this data frame past data frame is available at all the nodes, it does filter first, filter here, also do group by here.
Means that portion of path RDD is spread across multiple nodes. This is what you meant, right?
Yeah, automatically using Spark. Okay, and how it is said in sense, if this RD can fit in the memory, then it is distributed to memory of the all nodes. Okay, if it's a very huge RDD cannot be fitted to the memory, then it will go to a DFS.
And you can control it.
Yeah, using this. Okay, so this is done, right? Filter and group by, filter and group by, filter and group by, and it will have some data here, right? Like keyword pair, something, whatever. So computed every pair. So again, it will have same similar way here. And then now you want to show it technically it will does the reduce and combine everything and so at the driver node here. So technically, when you create the cluster, you give little extra memory and resources to driver node because sometimes it has to compute very high level.
So the
Transformation.
output would be in memory and shown to us and then dropped away.
It depends.
You don't say.
It depends. If you want to save to text file, then it will be saved text file. If you want to pull that to Kafka streaming, it will be streamed to Kafka stream. If you want to map to the Kinesis, it will map Kinesis, right? If you want to dump into Postgre, it will be dumped to Postgre, right?
So for example, now the node one, it has come as a group by 5 cores. In the filter 2, we got the 6. So in the driver node, 6 plus 5, 11, it will make it again computation.
Yeah. So for example, first node got failed, right? Since it has a replication factor, it will move data automatically to second node and do computation without your information. So limit 100 and so 100. So if you do so 100, then what will happen? It will bring everything to driver and then it will show you 100 rows. Then you know that limit can only get 100, okay? And then only do so 100. So you save data and stuff like that, right? It will take some time. I mean, it's not that straightforward, but the way you will practice it will come.
But if we write only show 100, it processes all the data.
Not process, it's bring all the
All the data.
rows, okay, coming from the group by and filter, and then it will cut down 100 and show you 100.
Yeah.
Okay, so because since you know this is enterprise cluster, everyone else is also doing processing. Let them also give resources, so everything will run well. Okay.
So limit is not action and show is an action.
Yeah.
So that's why we are limiting in the
Limit is, see,
Limit is not
limit is even action, but I think limit is action
limit is action.
because it has to cut down the data because it cannot be done 100 and 100.
So it processes on the driver level, right? Limit also on the driver.
Limit is not computation, right? You just take 100 limit.
Yeah, right.
I don't think you have to compute something on that, right? Computation is already being done. Just take 100, cut down from that entire set of data.
Take off 100.
Yeah. Limit is same limit that you do in SQL, right? You select star from something and limit.
Yeah, right. Yeah, that's right. I'm just trying to understand like that limit of operation happens at the driver level or it is in the workload.
See, the data stays at node level.
Worker
So
level,
when
yeah.
you call limit, no, it has to go to the node and fetch the data, and it has to fetch, see where to fetch the data from. If one node has 10 data only,
It depends.
it will pull the 10 data from one node and go to the next node. So it will do internal calculations to calculate where to fetch the data from. That is where the limit is.
For example, if you have
It is not actually fetching of data kind of. So it has to do some calculation to see where to get that 100 rows of data or what data from. Then when you call the show, it has to pull it from the nodes to the driver and for further processing.
So both limit and show are actions.
says
For me,
sorry.
limit looks like a transformation. That's what
It is not transformation when your data is stored at all the. See, for example, you think in that way. If you have worker node, it has only 10 rows, right? That it there's no point to apply that over there. So I mean, this is very smart framework. Okay, it does calculation. It has physical plan. It has all the plan. It does some statistics inside that, and then it will give you that. But it's not clearly mentioned that limit can be used as a worker node. Or see, there could be possibility that all the data can be fitted to one node only. There's no requirement to go ahead to distribute, right? In that case, limit will be your transformation, but so is action. There's no doubt on so.
Yeah, right.
Even though you
it's an
distribute
action,
or
right?
you
Yeah.
don't distribute at all. Yes, Amy. So this is a similar way to compute same thing in a SQL way. So when you have Spark.SQL and then you do select Spring, some of the number of stories count from audits where logic is equal to finance and group by Spring limit 100, right? So in this case, it will compute at all the nodes, and when you do so, it will give you a driver nodes. Okay, the same thing. This functional way to doing same thing. Okay, where you say data.group by department average age, and then you apply the SQL transformation like select depth. I mean, if you go with data frame way to compute group by an average, this is high level API in second line. And if you want to do in SQL way, select department average age from data group by 1. This will give you same thing. If you want to do in RDD way, okay, this RDD is again without column names, right? So you have to do case department age, and then you say department and age is 1, and then reduce by key, and then you provide this comparison 1 plus 1, whatever it is, and then again you create map and department age and C, and then you do department age divided by C. Okay. So this is it's not high level, okay? It's not easy for everyone to compute in RDD way, okay? That's why they have come up with the data frame and SQL way. But at some point of time, like if you work with Hive, Essbase, Cassandra, you will get data in RDD only. Like if you have text file, you don't have any other option. You cannot create data frame. You need to only go with RDD way. If I tell you that you need to process the Spark logs, right? Some application servers log, everything comes logs can be unstructured. So if it's unstructured, then you have to go with RDD and then manually filter out and compute that engines. So this is how Spark thinks, okay? That how if anyone is aware with push down queries, you bring predicates up and then you first filter out data. Even though if you work with Postgre or Oracle or MS SQL Server, nowadays they have kind of physical plan tuning, okay? It's not only the way it brings all the data for you. It does, if you have where clause, on condition, on join, right? So it first filter out the data and then give you the output here. So Catalyst engine is the engine which supports to, so you provide some code, right? As Scala code, Java code, and then that's where Spark works. But Spark will create the Spark framework will, as a toolkit, it will create one more Java code, which can be given to JVM for running, right? That will be very high level based on our code. So if you provide data frame, data set, it will create unresolved logical plan, and then again it will create the logical plan from that, and then it will create optimized plan, logical plan, and then it will create physical plans. So physical plans, it will compute which way is better now, whether it does work to distribute all the nodes to all the data to all the nodes and do limit, or it does work based on the data provided to bring everything on driver and then compute, because it can see the size of data, it can see the kind of expensive operation you are providing, and then it will create the cost model. Cost model is nothing the way you do statistics of the data. On a standard deviation, it provides the curve, which is faster way of going over there, and it will create a selected physical plan, and then it will convert to RDD. You may wonder that again we came back to RDD, but believe me, this RDD is very efficient, fast, and very high level. Okay, it is technically nothing but the Java POJOs on, very big Java POJOs, and that Java POJO is submitted to the Spark JVM to execute that. But this internal process, this explains you that how Spark internally works. But there's no need for you to know if you want to become the Spark developer to know this everything. But this is a high level way that how Spark converts their code internally and how
Even for the SQL request, the RDD is greater.
then it don't create RDD. If you use SQL, it will create the data frame, because SQL goes to Spark SQL module in the entire Spark. But you understood, right? If you use the entire SQL, what problem can come, like analysis error?
Because here we have put SQL AST, data frame, and data set.
SQL AST, yeah. So I'm saying same thing. Even though you provide SQL script, SQL string, now Spark has to break the SQL.
Yeah, right.
It has to understand what are the filters, what are the push down, and then bring that front. Okay, so it takes some time, right? Some time, seconds or minutes, whatever it is.
Yeah.
So you're saying that whatever code program that we give, it converts into again its own code.
Own primary abstraction, right? I think when you work with Java, the code you write Java, it will convert to bytecode and high level
Yeah.
Java POJOs, right? At the end.
Because in this flow chart, the final I see something called RDD.
Yeah, that's what I'm saying.
Whatever kind of request we give, finally it is processed.
But this is not the same RDD that RDD I explained you earlier.
Intermediate output or final output?
This is a final output,
Final
not intermediate.
When you give data frame, it could eventually go and
Because even though you create data frame, the abstraction is created using RDD only.
okay. I was expecting that if I get data frame, it would eventually give me output in the data frame as well.
It gives output in data frame, but it looks being a developer, it will give you output in data frame. But internally,
Internally, it is
the
RDD.
transformation happening in the entire technology stack is RDD itself.
Okay.
Now it's boring.
Is it?
Yeah, I can hear it.
Is it running or?
I'll just continue. I'll quickly talk.
Okay. So now we will talk again very high level API called dataset API in Spark 2.0. So if you want to read something spark.read.json like employees.json, it's very high level. So there's no need that JSON will convert it to tabular format automatically. It's just 3 words, spark.read.json, okay? And then you can create your domain objects like case class, employee, name, string, age is integer. So case class is nothing but similar way you create class in Java. It has automatically constructor, deconstructor, and it does automatically for you getter setter. Okay, if you want your own getter setter, you can define that. So the advantage here for you is that employees dataset of employee. So here you are using type safety, okay, and then you are saying that employees df as employee, okay, and then you say filter ds employees ds dot filter. So now you got this. You can define anything here, alias, if you say employees DS is here, and then filter P. So now after P dot, you will be able to access this this key attributes here, and then you will say greater than 3. Why it's provide type safety here? Because it understands age is integer type, so you have to provide 3. If you're providing string, it will fail in compile time. But if you use data frame or the Spark SQL way, it will not fail. It will fail in runtime after 8 hours. Okay, and that time it's very late to understand that why it failed. But if you go with this approach, you will get to know everything on compile time itself. Okay, but same thing can be done in 3 ways. Okay, and sometimes it's very tedious to do in this way. And if you are very confident,
So, if I at all give a value in string, so somewhere in some node it is stored actually. So wouldn't it be getting error only when reach is there? Like in the case of data set or data frame, whatever it is.
if your job is running on different nodes, right? And due to the
one node it is string. Rest of node is fine.
it won't be
The paid node will fail.
fail, but
The other valid nodes will get processed and we get out.
but it can process. But I mean, again, if same data frame gets spilled over to second node, same issue will be there. But I'm not talking about some is integer, some is string. Just get example like it is you know it is only integer, okay? But by mistake you have provided string here. In that scenario you can guess, right? If you have some of the string and some of the integer,
Then
then
chances somewhere corrupted data may come.
I mean, then you need to handle in a Scala way. Scala is very big function programming language. If you understand, I mean, different they have different fundamental. But this is I'm explaining the fundamental that how it can
Thing
change.
is, at all the column type is wrong, then it will at the beginning you get the error.
But see, it's not only like you don't know. When you know at that time, you're providing this way here, right? You know already the type is integer and string here, right? But understand this is done by someone else in your group, because it's right now it looks very small to you, but when you work in entire team, this mapping is created by someone else, and when you are doing this filter, at that time you get confused and you do string weight and then you get failed, right?
Now I was wondering that when we set the data set and data frame in the calculator, it will be like saving the time. So I was just thinking about
Saving time because you have the type safety here. Okay, if you don't go with
we do not have that thing.
no, you cannot see if you see as employee. Okay, so when you do as employee, data frame is converted to data set. But you again understand, see, data set is nothing but data frame of type safety. It's data frame only, right? So technically speaking, your data set is nothing but you have data frame of some type. That's why it has type safety. And again, this data frame is nothing but some kind of RDD only at the back. Okay. And you can operate on this. You can operate on complex domain objects if you know the structure of data, and you can apply all the high level lambda function on top of that. So this is how it works. For example, in this example, you have employees. Okay, employees is a one table. Understand from MySQL. Events is one file. Okay, and then you want to join together, and then you want to apply the filter. So here, if you see here, you are doing employees.join events, and employees ID is equal to events ID. Okay, and filter events date greater than 2015 1st January 1st. Okay. If you will do in this way, this is what it will happen here. Okay, it does filter, it join and does filter. Okay, and physical plan will be how this way. Scan, and I mean Spark is very smart. It understand that you are applying filter, right? So why can't we first do filter from this employees where no, from events where data is very less. Okay, and then does the physical plan. And when you do this, you have optimized scan, employees, and then it does join. So I mean, as I explained earlier, it can different plan, and then it applies the cost model. Okay, which can run very fast away and choose from that plan and then run it on top of that. Okay.
It means that it won't go in the same sequence as we have given initially?
No, it won't go in that sequence because it understands how SQL works better way. But I mean, if you understand, then you can save this time also, right? So for example, you are saying events date is greater than 2000 something, right? So if you move this code, okay, if you apply events.filter, where column date, this is kind of pseudo code, this is not the syntax, okay? Events.filter and say column date is greater than 2015. Okay, so then what will happen? Entire events is nothing but the file will bring only data that you need on the cluster, so it is faster.
But first condition ID equal to EID, that has to be checked as well, right?
Yeah, then fine, because even though this is nothing but a join condition, right? This is between this and this, right? When you join it, you will say this. You need some matching condition, and at the end, if you reduce those number of records and then join, you will have same output. There's no difference in output, right? So data frames are faster than RDD because it has named, it has high level API. When I say faster, then when you do this kind of bigger operation and transformation and load and data is very faster. But at the end, as you know, everything will get converted to RDD only when it gets executed. So this is basic comparison chart from the founding company who started about the Spark. Right. I mean, basically, data frame is faster than RDD, and RDD in Python takes time because it has to convert JVM calls back to Python calls and back and forth with Py4j or something other frameworks.
So Python is costly as well.
Because Python is untyped, one thing.
Okay.
Python cannot run on JVM.
Right.
Okay, so they have to convert all the calls back to.
So one more
JVM. Yeah, I mean, because why? Being community, why we need to provide Python API? Because most of the people we are working machine learning or they are working with a numerical computation. Python is work better than JVM, like NumPy and SymPy and Pandas, scikit-learn or TensorFlow or PyTorch. These all APIs, right? So if you want to become the familiar in the market, we need to provide this API so people can use it. Okay, that's why we have provided the Python API here, so they can use that. And some of the people who are analysts or statisticians, they use R, so we provide the language R. But the advantage they will gain, rather than they doing a single node, if they use the Spark, they will get advantage of distribution fashion, right? So their data will be faster, and those things will work. Yeah. So dataset takes less memory than RDD. Okay. So this is used by Tungsten engine because it has to. There's no need to compute when you use dataset because it knows type safety and everything. So it takes less memory. Okay. And serialization, it came up with. So Spark was not supporting Java serialization earlier back 2016, but now we are supporting Java-based serialization encoders. So, I mean, there are some changes in serialization encoders, but if you use the Spark default encoders, it performs well than Cairo or Java serialization here, but it can work. Okay. And these things come when you are doing text file-based things much more sense. Okay. Anything? What is time, Hemant?
We are done on time actually.
Okay. No, there is something to cover, but then we'll cover later.
Yeah.
Another thing, like you talk about RDDs and all, right? RDD operates in memory and everything and all. So every time it transfers the data for each and every request to memory, or it's a one-time transfer, and whenever the.
If it is in memory, then there's no need to transfer because it is already in memory. Okay.
But underlying data is in HDFS, right?
Why? If your data can be fit in memory, then there is no need to fit in DFS also, right? Yeah. Because this memory is getting cheaper,
Yeah,
right?
right.
So this people are changing the paradigm from imperative paradigm to functional paradigm. Okay.
Okay. So each worker node's memory will have this data distributed.
Yeah, if it can be fitted to memory. Okay. So now again, if you have disk and it's slow, you can use SSD. Okay. It's all about the way you get your infrastructure and your architecture. Okay. But it's very general purpose. It's very flexible. The way you want, you can control it. Okay. I mean, you can tell them you want to. If everything is fitted to memory and you think that it's a very big table, if you will feed this to memory, other people cannot run their jobs because it will eat all the memory. Then you can serialize back to disk. Then you have to just say data frame dot persist dot to disk, and then it will persist to the disk.
And one more thing is, if I have
And then you think, no. After that, there are other computation that can be free. Then you can do unpersist and then back to memory.
we have different source systems like SAP and state schools and all those things and all. How to bring in the data?
You use the JDBC driver and bring this data to memory.
Data to Spark.
So technically, Spark ecosystem has Spark packages.
What is the tool used to bring in those data?
It's nothing but you need to use Spark packages.org, figure out driver for the Spark, and connect with the driver and pull data.
So there is something called Scoop or something like that.
That is one of the old tools. The Scoop was used to get data from RDBMS to HDFS and back from HDFS to RDBMS. But Scoop cannot perform the way fast Spark can perform because Scoop cannot use the memory and it has to use the disk. That's all.
So everything can be done in the Scala itself. Right?
Yeah, Scala.
How this Google Clouds and all work? They have Spark.
They use same open source Spark because they business model. See, it's very simple, fundamental. Being a community, okay, we cannot. So those people are working to bring the Apache Spark as a bigger technology stack, right?
Yeah.
You need people, and if those people are not getting paid, why should they work? So Google, Facebook, and those big giant people will fund them. So you work on open source tools, okay, and then come to Google and give the talk. So they will bring their product based on the open source technology, and they can get everything from the okay. So it's very simple, fundamental. Like if you don't have expert Scala or people in Spark, you use the cloud system and go with that.
They even the technology, like it just came from Google table. So
Yeah.
they had it, then we did.
So
Gave the Apache.
yes, but I mean there are law and licensing part and some ethics you have to follow in open source community.
So this is the technology side, but from business side, when would I know that I need Apache Spark and I need to do all this?
When you have a huge data, when you want to do analytics, when you want to do computation, you need very faster way. At that point of time, you can use Scala and Spark.
So advantages, take the advantages and use it based on the features that we need. So I clearly see that, okay. So if I use some Python to get doing it, data processing. So
Can I stop sharing now?
Sure, please. Thank you.
Because we may get.
You share. I mean,
Yeah.